Okay, so in this video we're going to look at how to draw alkanes and alkenes, and we're going to use some of these facts you see here. Most importantly is the fact that carbon forms 4 bonds. Okay, so let's have a look. First of all, we're going to look at alkanes, and these you name the alkane depending on the amount of carbon atoms. So methane is the first. It only has 1 carbon atom, and as we saw on the last slide, methane or carbon always forms 4 bonds. So here I can see this carbon, and it has 4 bonds coming out from it. Now we could draw hydrogens on the ends of each bond here, but because we're talking about hydrocarbons and hydrogen is so common, it could take us ages to write all these little H's in. So in practice we don't usually bother, we just leave them blank, and that indicates that there are 4 hydrogens there. So if we know the structural formula shows us what methane looks like, and we can work out from there the molecular formula, and the molecular formula tells us how many of each atom are in the molecule. So carbon, you can see it has 1 carbon atom in methane, and there are 4 hydrogens, so the molecular formula is CH4. Let's try ethane. Ethane is the next in the series. It has 2 carbon atoms. Each of those carbon atoms has 4 bonds, so both using 1 here. So we have 1, 2, 3, 4. 1, 2, 3, 4. So there's a molecule with 2 carbon atoms. Oh, so I need a little 2 there. And then how many hydrogens? 1, 2, 3, 4, 5, 6. So the molecular formula is C2H6. Propane has 3 carbons, so 1, 2, 3, and again each carbon must have 4 bonds. So these are all bonded to hydrogen. Carbon in the middle has 4 bonds, but 2 of them have been used to bond to the carbons either side of it. There we go, and that's our structural formula. So if we try and work out our molecular formula now, well, it's easy to see that we've got 3 carbons, and this time we've got 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. So hydrogen 8. And for the last one, butane, we've got 4. And each carbon uses its other bonds to bond to hydrogen. Sorry, that's completely unlinked. Different atom, different molecule. Okay, so how many hydrogens have we got on this atom? Oh, on this molecule, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's C4H10. Now there's a pattern in the numbers here. You can see as the number of carbons increases, 1, 2, 3, 4, the number of hydrogens always increases. And we can write that down as a general formula for all alkanes, and we can say that the number of hydrogens will depend on the number of carbons. The number of carbons could be any number, it could be 1, 2, 3, 4 or larger, so we say Cn, and the number of H's depends on the number of carbons. Now it's actually 2 times n would be here, so 2 times 1 would be 2, but there are another 2 added onto it, so it's 2n plus 2. Let's try out this formula with the next carbon atom, C2H6 or C2. If we work out the number of hydrogens, 2 times n is 2, which is 4, plus 2 is 6. Great. So that's alkanes. Next, if we look at alkenes, there's the same prefixes on the words here. Meth meaning 1, eth 2, prop 3, but 4. But this time we can't actually draw methane. It doesn't exist, and we'll see why now. The definition of alkene is something where the carbons are bonded together with a double bond. So if we draw ethene, we can see that we need 2 carbons at least to bond together with a double bond. So you can't have methane. So the structural formula for ethene would be, we've got C2. Now how many hydrogens have we got there? Well, the number is going to be slightly different this time, because carbon's only got 4 bonds. So here, this time, only 2 hydrogens can attach to that carbon and 2 to this one. So we've got a molecular formula of C2H4. Look at propene. We just draw propene with 1 double bond. So we're looking at 3 carbon atoms and how many hydrogens? Well, 1, 2, 3 for that carbon. This carbon's already using 3 of its bonds, so it can only attach 1 more. And this carbon's using 2 of its bonds, so it can attach 2 more. So how many hydrogens do we have? 1, 2, 3, 4, 5, 6. And the last example, butene. So of course there's 4 carbon atoms in this chain, and this carbon's already using 2 of its bonds, so it can only bond to 2 hydrogens. This carbon atom is using 3, so it can bond to 1 hydrogen. This carbon atom is already using 2, so it can bond to 2 hydrogens, and this carbon atom is only bonded to 1 currently. So there we go, it's got 3. So in total, our molecular formula would be C4, and how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. Now, just as we saw a pattern in the alkanes and came up with a general formula, we can see a much simpler pattern here. The number of hydrogens is double the number of carbons, so we can say that the general formula for alkenes is CnH2n. So we can use these general formula to predict the molecular formula for any alkane or any alkene. If we said this was the general formula for alkanes, I could say to myself, what would the molecular formula for an alkane with 7 carbon atoms be? I could work out that if it had 7 carbons, the number of hydrogens would have to be 2 times 7, which is 14, plus 2, which would be 16. And the same goes for alkenes. If that's our general formula for alkenes, I could say to myself, what would the molecular formula be for an alkene with 20 carbon atoms? I could say, 20 carbons, the number of hydrogens would have to equal 2 times 20, which would be 40. There you go.